These massive clouds can weigh hundreds of tons. Yet they float effortlessly in the sky. What is this mystery? Clouds are actually made of billions of tiny water droplets and ice crystals, formed around microscopic dust particles in the air. It all starts on the ground. The sun heats the surface, which in turn warms up the layer of air directly above it. Warm air is less dense than cold air. The warm molecules spread out, which makes them lighter and causes them to rise up. This phenomenon is called Archimedes' Principle of Buoyancy, just like a balloon rising in water. The warm air is pushed up. But why doesn't the water fall? The incredibly small size of the water droplets means they are strongly affected by air resistance. The continuous rise of the warm air creates steady columns of rising warm air called thermals or updrafts. These persistent updrafts constantly push the super light droplets upwards, countering the pull of Earth's gravity. We can't see it, but the air is full of water vapor, especially when the air is warm and humid. As the warm, moist air rises, it cools down and reaches its dew point, forming the condensed droplets we call a cloud. A cloud stops rising when it reaches an altitude where its density equals that of the surrounding air, known as neutral buoyancy. Visualize a cloud as a large parcel of warm, moist air encased by the cooler, denser air around it. Each tiny water droplet in the cloud is technically falling, but at an extremely slow rate, just a few millimeters per second. The power of the atmospheric updrafts is strong enough to easily overcome that negligible, slow falling speed. Air temperature decreases with altitude. When the warm air meets the cold, it condenses and loses its momentum to fly higher. In reality, clouds aren't truly floating. They are being continuously held up by the immense buoyant force of the air below. Even fog, which is essentially a ground-level cloud, demonstrates this delicate balance of gravity and air push. The entire atmosphere has incredible lifting power, which is far greater than the total weight of the cloud itself. At very high altitudes, the water in the cloud freezes into ice crystals, making the cloud even lighter in mass. Smoke rising quickly from a fire is a perfect visual example of how lighter, warmer air pushes matter upwards. In large thunderstorms, powerful updrafts can push the cloud mass vertically for tens of kilometers. Only when droplets collide and combine into a heavier raindrop is the cloud water finally falling to the ground. After it rains, the cloud remains, but the heaviest water has departed, leaving the remaining mass much lighter. Clouds begin forming when the rising warm air reaches a specific height called the lifting condensation level. Wind blowing over mountains is forced upward, creating a similar lifting effect that results in the formation of clouds. Air is not uniform. There are always complex, turbulent movements both inside and surrounding the cloud. Even a single snowflake descends very slowly due to air resistance, showing how effectively air can slow matter down. The terminal velocity of a tiny droplet is so slow. They appear to hover until they grow much larger. Clouds arranged in layers or rows are a result of organized, large-scale air movements. Remember, the cloud is only a tiny fraction of the massive volume of air beneath it that provides continuous lift. Clouds cast shadows, proving they are matter, but they are supported by an invisible ocean of air. Scale is key. Although a cloud is heavy, its mass is distributed over an incredibly large volume of air. Stronger winds at higher altitudes can sometimes tear clouds apart, revealing their fragile composition. A rainbow only appears when light passes through millions of small water droplets suspended effortlessly in the air. Airplanes pass through clouds easily because they are just concentrations of water vapor, not solid barriers. Clouds are dynamic structures, constantly evaporating at the edges and condensing on the inside. Frost on a window is an example of water turning directly from vapor to solid, part of the cloud-making process. Large-scale differences in atmospheric pressure also act as drivers for the movement of large cloud masses. Lens-shaped clouds over mountains show air moving in waves, holding the cloud in a stable, hovering state. A cloud droplet is about 1 million times smaller than a typical raindrop, so its individual weight is negligible. The buoyancy principle explains it all. A lighter volume of matter is pushed up by a heavier volume of surrounding matter. Thin, wispy cirrus clouds, high in the atmosphere, are made almost entirely of light, delicate ice crystals. The edges of clouds are often fuzzy because the water droplets are constantly evaporating back into invisible vapor from space. The Earth's atmosphere is a thin film where all weather phenomena, including clouds, exist. In short, clouds float because they are lighter than the cooler air below and are continuously supported by rising warm air currents.